All right, recording has started. And so what I'm going to do is I'm going to go ahead and introduce here. Welcome to the ISA Twin Cities section. This is our November 2024 Tech Talk. Tonight we have Ed Naranjo. Is that how I say it, Ed?
Yeah, you said it right.
I can't believe that. Ed is a business development manager for fire and gas systems at Honeywell. He has published over 20 papers on flame and gas detection. He obtained a Bachelor of Science and PhD degrees, both in chemical engineering from Caltech and the University of California, Santa Barbara, as well as an MBA from the University of Chicago. Currently serves in the executive board of the International Society for Automation and is also an ISA fellow. So with that, Ed, I'm going to turn this over to you for your presentation on protection against hazardous material releases in energy storage systems. So
okay, thank you so much, EJ. Well, as he just said, much thanks for the group for being attending this call today. It's great to be here. I think that I am quite privileged to be working on process safety. It's a subject that I cherish, and I've been doing this for quite some time. And most recently, I got involved with battery energy storage systems. They are an enabler of new technologies for smarter grids, for the use of renewables, but they're not devoid of their own risks, and those risks have to be understood. So I will go through a presentation that will comprise of the following elements. I'll talk on a safety moment to begin, and this is a safety talk after all. We'll talk about battery energy storage system fire and gas safety, what has been done to improve safety of these systems, what kind of flame and smoke detection and even gas detection are used, what are some of those approaches for fire protection, and lastly, I'll talk a little bit about standards related to BESS safety. All right, so to begin on the safety moment, there was, and this is back in 2019, a pretty large explosion that occurred in a battery energy containment unit that was part of this corporation in Sunrise, Arizona. It's actually the Arizona Public Services Corporation, and the site is called McMinn. As it turns out, one of the cells in this particular container had a runaway reaction, and it propagated to the point where the accumulated hydrocarbon gas was above its upper explosive limit, and as a result, it could not sustain a fire. And yet an alarm was raised, and a number of firemen went to investigate the incident, and upon opening the door, air went into the container, reducing the gas concentration to the point where it sustained an explosion, and an explosion did in fact occur, and it injured four of those emergency personnel. The likely cause of the incident was an internal failure of a single battery cell. And once these failures occur, because of the heat that is emitted by these batteries, they can start propagating, and they can start burning other cells, releasing additional hydrocarbon gases, even toxic gases, and it creates a bit of a cascading effect. In this particular case, it didn't go that far, but the explosion was sufficient to injure personnel. Luckily, no one was killed, but it is just a reminder of what can happen in one of these units. And it's a fair thing to investigate what happened, and there was, in fact, this has been one of the most investigated reports on battery energy storage systems that have occurred. And there are some salient observations. One of them is that the clean agent that was used for the fire suppression system was not designed to prevent or stop the thermal runaway. So you had a measure for the reduction of the consequences of the escalation of the accident that was wholly inadequate. This is not new. It has been the case that in other industries, many of the extinguishing systems that have been used have not been wholly appropriate. It's actually more a symptom of an industry that hasn't come to terms with its own risks. And as a result, it doesn't have the maturity of other industries, but it is not that uncommon. The second one is that there was absence of any barriers allowed for thermal runaway. So when you have batteries or cells rather that can be isolated and compartmentalized, you can protect or at least reduce the scale of the incident by ensuring that one single cell burns without affecting the other ones. In this particular case, there was no such thing. There were no passive barriers to protect other cells against one single failure of one cell. The more salient problem of all is that the flammable of gases did not have any release. There was no venting, and as a result, all of these gases accumulated in this container. The container is one small volume, and it created a flammable gas concentration. And of course, upon increasing that concentration, you reach a level above the upper explosive level of that particular mixture. And here you have a situation where opening a door, opening a vent can result on the mixture becoming explosive within a few seconds. So that was yet another observation of the incident. And the other ones have also an important effect. There was not an emergency response plan. But I think that perhaps the most important one of all is that back in 2019, it seems a long time ago, it's 5 years, but back in that day, the National Fire Protection Association Standard 855 did not exist. This is now the prevailing standard on the installation of stationary energy storage systems, and many of the safeguards that could have prevented this incident from happening were not in place back then. So what are some of the contributing factors to continue with this particular incident? Well, I just pointed it out. NFPA 855 did not exist back then. But I would say also that there was just no way of shutting the fuel supply of this particular release. There was no fire service, or at least the fire service was unaware of these particular types of fires. And I think that you're finding this more and more as we are embarking on this enormous growth of the battery energy storage industry. Fire marshals are just not keeping up. It's a new technology. The fires are unlike those that they have seen with a standard fires in the food service industry, or perhaps some chemical process industries. A battery fire from a lithium battery will burn very intensely. It has the same intensity as an acetylene fire, and it can melt metal structures rather quickly, and it doesn't burn. It doesn't, you cannot use standard extinguishants in order to extinguish the fire. So that's as far as fire service is concerned. And I would say that the last one that I think is very pertinent to this conversation is that if we look at the actual schematic involving the the container, even though there was an extinguisher in place and you had these 2 points of release, there was no sensors for flammable and toxic gases. So, well, you may have had an event that could have created the activation of sprinklers, or in this particular case, the offloading of a fire extinguishant. If you don't have a flammable gas detector or a flammable detector or a toxic gas detector, you would never be able to extinguish that fire. There's definitely not the type of sensing mechanism required. All of this is to say, and by no means I'm picking on the Arizona Public Service, is that the safety standard around energy storage system is rather poor. The industry is going through its growing pains, and unfortunately, the rest of us need to catch up with it. According to an industry group called Clean Energy Associates, more than a quarter of inspected energy storage systems had some sort of quality issues. In fact, it was 26%. And the most common quality issue was faulty smoke and temperature sensors. And in addition to that, about 20% of the audited BESS units had some defects in the thermal management system. So this is not to pick up on APS. This was an accident, but I would say the industry, at least the installation that we have as a whole, has some deficiencies that must be addressed. So let's talk a little bit about BESS facilities overall. They have been growing like gangbusters. It doesn't take much for us to see in the United States, in Western Europe, in Southeast Asia, in China, that battery energy systems are in fact the enablers for a smart grid. If you want to use solar energy or wind turbines in order to generate electricity, all of these systems are completely intermittent. So there has to be a way to balance energy storage in those periods where these renewable sources of energy are not operating. Right now, BESS are growing at about 29% per year, and in the United States alone, battery capacity this last year increased by 89%. It will probably break that by the end of 2024. So no doubt, it's a hot industry, it's growing, there's a good reason behind it, but we have to do it in a safe manner. So how is the safety segment catching up with this? Well, it is doing so by requiring end users to abide by certain codes. And in fact, I would say the adherence of codes offers the best approach to reduce risk. I pointed out before that if 855 had existed in 2019 and the end user had abided by 855, I think that the incident may not have occurred. Some of the things to be done quite readily is to equip BESS with exhaust ventilation for releasing off gases caused by developing lithium fires. In fact, most containers post 2020 already equipped with some sort of ventilation system, and I'll go into detail later on as to what their prevalence is. Another one is, as I pointed out, it's necessary to install gas detection or smoke detection within the enclosure. Don't wait until your sprinklers get activated, because there are mechanisms for failure that will not involve radiant heat to be produced. Installing automation sprinkler protection is also required. But I would say overall, what we need to do is use 855, and I will also make reference to another standard called NFPA 69 for protecting BESS units. Oh, I see here that my cartoon didn't come out as I expected. I apologize. NFPA 855, like other NFPA standards, are prescriptive, but to a degree. They allow for some latitude of the end users to develop the type of fire protection that they deem most appropriate. 855 simply points out that end users must equip their BESS storage system with some sort of flame or smoke detection. That's very, very important. It's only flame or smoke. So the umbrella standard just speaks to those detection technologies. However, there is a standard called NFPA 69 that does require gas detection. And if you're using fire protection or active fire protection as your method of prevention or mitigation, then gas detection is required. On the other hand, and that's NFPA 68, if you must have or you choose to have a passive method of protection, then your system must be equipped with some sort of venting. So you don't have a choice. You either have venting built into your container in order to prevent explosions, or you're using active fire protection and gas detection is required. So it's either or, and both are perfectly acceptable under NFPA 855. Now, what I would suggest if we were to use active fire protection is to have a holistic approach to it. It is often the case, and I have found this, that operators use one single detection method, and most likely they believe that that is enough. I would not be surprised that APS, for example, back in the example that I used in the safety moment, thought that having a single extinguishant with some sort of heat sensor was enough. But as you can see, there are methods or developing accidents that can foil that detection method. So the best protection is defense in depth, just like with cybersecurity. Just don't rely on a single barrier. Have multiple independent barriers. So in this instance, you can use a thermal runaway detector, which in fact is a preventive method because it detects a failure of a cell before that cell burns. You could also use high sensitivity smoke and gas detection systems, and this is typically used in large capacity BESS units. If it's a small unit, it's unlikely that you will need an aspirated smoke and gas detection system. Gas detectors, both for flammable and toxic gases, are also needed. Please realize that many of the gases that are emitted by these cells, whether it's because of the electrolyte or because of the actual cathodes and anodes that they have, they can produce benzene, carbon dioxide, carbon monoxide. Some of the gases are entirely non-combustible. They're not flammable, but they can be quite toxic. Well, one example that is combustible and toxic is hydrogen sulfide. By the time hydrogen sulfide can burn, the concentration is well above the concentrations that can kill a human being. And lastly, we have flame detection, and flame detection will always have a place in a BESS container unit under NFPA 855. Please keep in mind that detection technologies are complementary. Each one of them have their own deficiencies, but because these methods tend to be independent, meaning they share few common failures, they can serve as additional layers of protection. So what do these systems look like? Well, most BESS units, unless they are very large, I would say have very little space for sensors. Typically, one would have a control system that could manage a number of container units, and I'm showing this in the upper left-hand side of the slide. But inside the containers, you could have a thermal runaway detector. I have shown a Lion Tamer, which is a specific brand. You could have high sensitivity smoke detection systems where the actual box, it's either inside the container or just outside, and only the sensors are inside the container. Gas detectors and flame detectors are also quite common. These can be small, and they can provide adequate coverage for most installation. And of course, beacons and sounders, which are typically installed outside of these units. So just to conclude on this topic, battery energy storage systems are much, I mean, they're much needed these days. They definitely play a crucial role in this brave new renewable energy economy. They are the ballast. They help to balance energy and make the use of such sources as solar and wind energy much more reliable. But they are not devoid of such hazards as explosion, chemical, electrical, stranded stored energy hazards, and even physical hazards. So they have to be respected, and one must use specific measures to reduce the likelihood of having incidents occur. Lithium-ion battery fires are very intense. They're very difficult to contain. Most fire emergency responders are not trained on these fires, and as a result, there's much to be done in order to be able to protect the firemen, but also protect end users at the installation. And I think the McMigan BESS incident just illustrates the case quite well. The best method of protection, I would say, is simply to use the appropriate standards. I believe those to be quite adequate. And the main standard, as I pointed out, is 855, along with its satellite standards, NFPA 68 and NFPA 69. Lastly, I would say, please use the holistic approach. No one detection method is 100% effective, and having a wide range of gas and flame detection equipment, when combined with some sort of system that is scalable, has the best chance of reducing an accident, reducing the consequences of an accident. Any questions?
Because this was a particularly appropriate coming up on tonight for you to give this, as I saw a news article or a post, a LinkedIn post by one of my connections, and I was just looking for it. And she is a cybersecurity SME, and she was advocating for greater transparency by logistics companies in the transfer of lithium batteries to their new. Is that noise in your background, or is that here?
I'm not sure.
I think it's in my background. So sorry. Let me just.
Yeah,
It's all good.
you're in a work environment, so it was maritime application, and she had a video of a ship that had containers within its hull, not out on deck. And so I don't know if these were lithium-ion batteries that were new and being shipped, but they got too hot.
Mhm.
And they had or maybe there was a fire, an unrelated fire on the ship that caused the batteries to explode. So is NFPA 855, pardon me, is that applicable to maritime systems? I guess it would be if
It would,
it's,
yes,
okay, okay. And it can be applied to the logistics and the shipping of batteries, not just the use as a energy storage system, because it is an energy storage system. That's what a battery is, right?
Correct.
An energy storage system. So, you can use it in either way. Okay, thank you, thank you.
Yeah.
I'm gonna have to get your presentation elevated to some other folks, this recording tonight. Get it related to some other folks.
yes. What I'm finding, and this is I would say this is important. You will start to see battery energy storage units in hospitals. You will start to see them in government facilities. Just about anywhere where one person wants to have a standard source of energy along with, say, a generator. Not uncommon to see that. I mean, they're used throughout, and the standard does make a distinction between those that are within a building as opposed to those that are outside a building. But they definitely require safety measures, both active as well as passive, in order to prevent fire propagation. And I still say it right now, even though BESS is proliferating, there's no adequate method to stop the fire. The best method right now, or the standard approach, is to let the fire burn. It's just that intense. It cannot be stopped. The extinguishants that we use for hydrocarbon fires are wholly inadequate. There's some that are used right now, but they're not the best.
How about
So
the halogen? The halogen, which kind of removes the oxygen from the environment. Is it halogen that's used?
Halon.
Oh, halon,
Halon.
sorry, no.
Halon, yeah.
Yeah.
You don't, yeah, but it can burn without oxygen. So
Yeah, it oxidizes itself, doesn't it?
it oxidizes, exactly. It oxidizes itself. It's a metal fire. It's so it just, the best approach is to prevent the fire from starting in the first place.
But once it starts, just let it burn out. Okay.
Yes. Yes, that's why part of the best practice, again, this is an NFPA 855, is to put these containers far from, I mean, there's some minimum distance to a building for putting BESS containers. And if you decide to put them inside a facility, then there is a minimum distance to other structures for that reason.
Thank you, thank you.
I have another question actually to dovetail with Tom's about the logistics and transportation side of things. And does NFPA 855 also apply to electric vehicles that use lithium batteries, such as Teslas and other vehicles that are coming out now? Or is that a separate Department of Transportation code that they abide by?
Fire protection.
Yeah, so the distinction, and I don't know that there is a standard that NFPA has developed for electric vehicles, but it is, the standard is for stationary systems. So they have to be, yes, there's no standard for electric vehicles or storage systems that are for transportable energy storage systems, I imagine.
Question.
Yeah, no, that is intriguing. I have to see whether there is a, an intent to produce a standard for electric vehicles. Or yes. Yeah. Well, Yeah,
I would imagine the age of the cells would need to be mapped as well, because the older the cells are, the less, not only the less efficient they are, because they've done more duty cycles, but the greater chance of buildup of certain chemicals, of releasing different things. Is that something that needs to be mapped in terms of, best protection, whatever?
yeah. So, and that's typically done through operations, meaning these cells for energy storage have a specific life whereby they would need to be replaced. It varies; it's between 2 to 5 years. So yeah, so that is in itself a method. It's primarily due not because of safety. The replacement is carried out not because of safety, but because of efficiency. But it just happens to play a good role on using cells that are stable, that are not at the risk of having a thermal runaway because of their age. Oh, and another thing that I have to mention, I don't want to give the impression that the recent, very fresh batteries that are manufactured are more prone to thermal runaways than older batteries. Batteries that are manufactured undergo a lengthy process of monitoring before they are actually dispatched to customers. Okay, so that's whether it's a battery that is used for retail or sold to an electric vehicle manufacturer, for example, or is that it's used in a storage container. All of those batteries undergo, just like we have burning tests for electronic components before they're actually installed in an instrument, there's a period of monitoring of cells before they are dispatched for a battery container.
On the subject of fighting these fires, I do have a question. Has it ever been attempted to do a cryogenic approach? That is to say, for example, if you use a liquid nitrogen standby system and a fire were to occur, or a thermal runaway situation, since you can't actually snuff out its fuel nor its oxygen supply, in the spirit of letting it burn out but keeping it in a safe condition,
Yeah.
to dump then, so to speak, dump this liquid nitrogen upon it to simultaneously sap the heat from flame and also dilute those noxious and combustible fumes with nitrogen gas and just completely dilute it to the point where it's below that minimum explosion threshold. Has a cryogenic approach ever been attempted with controlling these fires?
I don't know. I mean, that sounds very intriguing. I don't think it has been carried out. I have been involved, or at least I have been approached about using new extinguishants. There are some companies that are very interested in selling new formulations, but no one that I know of is using liquid nitrogen or liquid helium, something that will immediately cool the surrounding structure. And yes, I think that I don't know. I mean, it's worth exploring. That's a good point. Yeah.
Take it from there and take that to the authorities.
I know. Maybe we have a patent coming up. Yes. Yeah. Well, let me ask you a few questions, and this is a little bit of it's a two-part trivia game for you. What type of hazardous substance are found in battery energy storage systems? And I have here 5 choices for you: corrosive electrolytes, toxic liquids, oxidizers, combustible and toxic gases, or all of the above.
All the.
All
Okay, you were paying attention. I am flattered. That's great. It is true. All of the above. Anybody who thinks these systems are innocuous, that, you know, nothing can happen, they have a thing coming. They may not look to be that dangerous on the surface, but all of these different materials are present in battery energy storage systems. Okay, which type of quality problems have been found with control and suppression systems? And I have here 4, and I mentioned one specifically. So loose cables, faulty smoke and temperature sensors, sporadic maintenance, and lastly, outdated or inadequate extinguishing systems.
B.
Exactly, it is B, is faulty smoke and temperature sensors. Imagine that. Okay, you're dispatching or these containers, which have a low probability of being able to manage if there were a fire and you don't have a smoke or an adequately operating smoke or temperature sensor. That's a big failure in my book. And the fact that there were over a quarter of those inspected with this type of failure tells me that we have a long way to go before we make energy storage systems safer. Yeah. All right. I think that is it. I don't think that I have any more.
More question.
Yes.
I know there are many types of lithium-ion batteries. Is there a shift to a safer type of lithium-ion, or even going back to other types of materials that maybe?
Yes. So the answer right now, well, this is the holy grail, but there are many companies, many battery manufacturing companies that are trying to find a battery that has a higher energy storage than lithium ion. There are batteries that are made out of silicon that are showing some promise. There's a company called Group 14 that is developing those. Let's see what else. Yeah.
Ultra capacitors, are they a real thing?
Not that I see it. Not for the type of volumes that we need for energy storage. I have not seen it. I mean, yes, but I definitely other materials are in the works. Lithium, lithium is by far the most common. It's considered the gold standard in terms of energy density. But I mean, safety is one of its downsides. The other one is just quite simply, the world's capacity for lithium compared to what is considered to be the anticipated demand. And I think between the two, there's plenty of companies that are looking at alternative sources for lithium, including silicon.
Well, one of them I am aware of is, and they've got a couple of different competitors, but it's a company called Gel Ion. Are you familiar with that brand?
No.
They're kind of revisiting some older battery technology. I believe it's a bromide salt battery is what they're working off of, and they've been around for a long time. Some of the earliest electric cars used a variety of bromine salt batteries, but essentially it's a distilled water electrolyte battery where there's usually some sort of a parasitic pump that siphons some of the electrical stored energy to circulate this distilled water, and then it's like a zinc, I think it's a zinc anode and a bromine salt cathode or something like that. And as the one dissolves, it migrates current to the other, and that's what it uses as its energy storage mechanism, as opposed to like a lead acid battery would normally. So an interesting concept. And if I remember correctly, they had actually deployed some battery energy storage systems. I don't remember what scale it was on, but it was very interesting. I remember reading about it and I thought to myself, well, that's a kind of a neat approach because those two materials are extremely common, far safer in terms of the flame hazards than lithium, because most of the battery is filled with water in the first place, and these substances are not at all prone to ignition or the temperamentality that lithium has. So I don't think they have nearly the watt hour capacity, the actual, the cycles.
Yeah.
But it's a good option for affordability.
It is an entire race right now to use materials that are more abundant on Earth and that are safer. But yes, I would say that the biggest driver is effectively abundance because of just the anticipated demand for batteries. So and it is, by the way, not only the cathode is the anode as well. The use of carbon, the use of different types of graphite. There's quite a bit of advanced materials all across the United States. There are so many companies that are on the race of developing, or at least having the components to develop more efficient batteries, and with as much, if not higher, energy density than lithium ion.
Yeah, and there's no good, safe, cost-effective way to recycle lithium-ion batteries, correct?
That's correct. That's correct.
That's all.
That's correct. We are we are at an age where sometimes we're getting ahead of ourselves. We see that the material has a lot of promise, but it also has quite a few disadvantages. And like anything, and I think this is why it's so important for us in ISA to stay abreast of these developments, is because this is not to disparage the renewable energy industry. It's just that, like any other industry, it has a number of technological challenges that call for people who have the right skills. That's why I think that's why we gather here. It's just a different set of challenges.
Yeah. Something for chemical engineers to do, huh, Ed?
Yeah. And I'm sure EJ is educating the new generation that will address many of those challenges.
Yeah. Thanks for the pitch, Ed.
Yeah, well, thank you, Ed.
Interesting. Yeah, thank you very much.
All right. Well, I hope that you found that review useful. I would say in passing, and this is not, to me, it's not uncommon. You have a number of companies that are, excuse me just for a second. I'll put the microphone on mute. Hold on.
Popping popcorn.
Okay. I just wanted to spare you for that noise. When I talk to end users of BESS systems, they're trying to in fact, I will tell you that most of these containers right now are manufactured in China. Most of the largest producers are Chinese made, and the safety features of these systems are minimal. That's just what they are, and I think that safety is an afterthought, and it's many are going with the the lowest viable safety system to be used. I think we have a long ways to go into having holistic approaches. I think that the industry needs them and is beginning to understand the need for it. But in this ramped up age, I think that a lot of manufacturers are still going with the bare minimum.
Go for the money, not the safety.
Yeah, to some degree, yes, yes.
Well, thank you, Ed. I want to, on behalf of the Twin Cities section of the ISA, I want to thank you for this tech talk. And as all of our tech talks, this will get posted to our YouTube channel, like all of the other ones, to become part of a library of all these great topics that we've covered. So I'm gonna go ahead and stop the recording now.